Hello! Today we continue solving problems, and the problem we are going to solve today is related to the concept of mixture. And there are quite a lot of such problems in chemistry. In fact, pure substances are quite rare in nature in general, and we can even find it difficult to name very pure substances. That's why we mostly meet with mixtures. For example, the air we breathe is a mixture. Thus, problems on mixtures also occur in chemistry. Let's try to solve such a problem. According to the condition of our problem, we know that we have taken a mixture of potassium salts. It is a mixture consisting of potassium chlorate or bertholate salt, potassium chloride or selvin, and accordingly, there is also potassium 2CO3, which is called potash. Altogether, these three salts make 50 grams by weight. This mixture began to be heated and the decomposition produced 5 grams of oxygen. And in addition to this, 7 grams of carbon dioxide was also obtained by decomposition of the mixture. And the question of the problem is as follows. Calculate what is the percentage composition of this mixture, that is, how much of each of the salts presented here in percentage by mass. So how do we solve the problem? A problem like this needs to be solved through a reaction equation. But first we need to see which of the salts presented here will undergo decomposition. Certainly potassium chloro3. Such a salt will decompose when heated. True, for this purpose you also need an appropriate catalyst, but in this case we will assume that it is available because oxygen can only be obtained in the presence of a catalyst. And potassium chlorine is produced and oxygen is released. It's during this reaction that oxygen is released. First of all, let's equate. We'll put 2 in front of the potassium chloro3 formula, here in front of the oxygen 3 formula, and in front of potassium chloro we'll put a factor of 2. That's our first reaction equation. Here it is, where the oxygen in our problem condition comes from. Now on to the second equation. Let's show for potassium chlorine. Will potassium chloride decompose when heated? In fact, such a salt is quite strong, and in this case, no decomposition reaction will take place for it. That's what the condition of this problem is based on. And note that potassium chlorine is a product of our first reaction with this substance, and nothing further happens. Then we are left to figure out how potassium carbonate, potassium 2CO3 will behave. Potash. This substance decomposes too, and it will decompose under the influence of temperature into potassium oxide and gives carbon dioxide. And carbon dioxide is exactly the substance that is also given to us. That's what we've been given by the problem. So out of 3 salts, we have 2 salts decomposing. Each of these processes produces its own gases. In the first case, oxygen. In the second case, CO2. So how do we solve? We'll solve starting with oxygen. Since we have taken oxygen in this reaction, we can calculate through oxygen how much berthollitic salt, that is potassium chloro3, has entered into the reaction. To do this, let us find how many moles of oxygen we have given by the condition. To do this, let's use the formula mass divided by molar mass. Substitute. That's 5 grams. And then we've got oxygen with a mass of 32 grams per mole. That's its molar mass. And then we have 0.156 moles. I'm going to take it with such precision that our answer is most accurate. And then I'm going to put 0.156 moles here at the top. And here we'll write x1 mole. Solving a simple proportion, from here we can find how many moles of berthollitic salt we have. And so the number of moles is 0.104 moles. But since we are asked about the percentage composition, we next need to calculate the mass of the berthollitic salt. For this purpose, the formula molar times mole works. The molar mass of potassium chloro3, if we do the math, is 122.5 grams, divided by a mole, and multiply by 0.104 moles. And then according to our problem, we have 12 whole 760 grams of this salt. This answer we need to then take into account in the calculation. Now let's go back to the second equation. We have CO2 from this reaction. And then we can find how much potassium carbonate we have in this case. To do that, let's calculate how many moles of CO2 we have. The same formula of mass per molar works. And then we divide 7 grams by the mass of carbon dioxide. That's 44 grams per mole. In this case, we have carbon dioxide at 0.160 mole because the grams are shrinking. And then we have CO2 0.160 mole. There's X2, and this X2 for potassium 2CO3 is obviously going to be equal in moles to the same value, 0.160 moles. But since we are interested in the question in grams, let's calculate how much it will be in grams. Now the mass of potassium 2CO3 is calculated using the same formula. It will be 138 grams. Multiplied by 0.160 moles. And in this case, we have a mass equal to 2208 in grams. That's what we found. Well, now we can calculate how much of each of the presented types of salts we have in our mixture. So, let's calculate how much of each of these substances we have. Let's start with potassium chloro3. So we've got 12,770 grams of this salt. And since we have 50 grams of the mixture, and we multiply that by 100%, the calculation for potassium chlorine O3 will be 25 whole and 52/100%. Here we have the first answer. Now let's calculate how much we have potassium 2CO3. In this case, we're going to divide 22.08 by the mass of the entire mixture as well, and multiply by 100%. And that gives us 44.16 1600%. And how do we find potassium chloride? We can find by subtracting from 50 grams, we can subtract how much potassium chloro3 and accordingly potassium 2CO3, but we can do much simpler. Since the total composition of the whole mixture is 100%, we can subtract how much potassium chlorine O3, potassium 2CO3, and the rest obviously is potassium chloride. It accounts for 30.32%. Here is our found another answer. Thus, we have solved with you a problem that involves the concept of mixture. Such problems can be more complicated. Some such problems are solved by complex and mathematical actions. But how we solve this problem, I hope, is clear to you, and you will be able to solve such problems on your own. That's all for today. Goodbye.